Is talking about the free throw that we did a couple of days ago. We are going to check your conditions for carrying out a significance test. So first of all, let's talk about conditions. What were our conditions that we needed to check? Normal. Where's one more? Independent. All right, random, independent, and normal. You don't have to do it in that order. It doesn't matter. Before we check the conditions, I want to show y'all, I want to show you the formula sheet. You don't have to get out your formula sheet. I just want you to look at this one. It's got this formula at the top where it says standardized test statistic. Y'all see that? All right, that's the formula we're going to be using. Statistic minus parameter over standard deviation. Well, if anytime you're looking for a standard deviation, it's going to be one of these two. It's either a proportion or it's a mean, one of those. The statistic minus parameter, it's going to end up being your p hat and your p. Now, they're two totally different numbers. P hat and p are different things. But that's the formula we are using this time. All right, so this person, the virtual basketball player, took 50 shots. The claim is that he or she made, well, we'll say he because it looks like a he in the picture, doesn't it? Proportion, he's claiming he makes 80% of his shots. But based on the performance, we're thinking that he makes less than 80% of his shots on a regular basis, right? All right, so if we're checking for random, independent, and normal, it's a little hard. There was no paragraph that said it was a random shooting. Oh, that sounded bad. Random shooting. Random shots. But when you're shooting free throws, don't you think that's just a random sample of shots? Right? It's a little weird. Normally we would have a paragraph that says random sample of whatever. So random sample of shots. We're checking the conditions. Y'all write this. How do I do my independent condition? It's not n greater than 30. That's the normal condition. 10 times n, yes. All right, the independent I condition is 10 times n less than or equal to what? Big N. All right, my little n was 50. So 10 times 50, we all know that as 500. What's the sentence? We assume there are more than 500 shots in America. That doesn't make sense, does it? In a season, yes. We assume that this person makes more than 500 shots in a season, is what you're saying, right? 500 shots in a game is a little hard. We assume he took more than 500 shots in the season. If you wrote 500 shots in the game, you would probably get credit for that, but it doesn't really make sense. Random, independent, normal. We're checking to see if it passes the normal condition. Many of you are thinking n greater than 30. That is a good thought, but not for this particular problem. For this particular problem, it's a proportion problem. What's the other way we check for normality? Okay, but there's nothing in our calculator. You're right, you're right. Somebody said it earlier for the I part. NP, that's it. N times P, and then n is greater than or equal to 10, and n times 1 minus P. The question is, what's your P? Let's go back to the original problem and see. What do you think your P is? 0.8. Yes, 0.8 is your P. What's your N? 50. So grab that calculator that's in front of you and do N times P. In your calculator right now. N times P. Is it bigger than 10? Okay. Then do N times 1 minus P. Is it bigger than 10? It is 10. But you know what the formula says? Greater than or equal to. So you're okay. I put 1 minus 0.20. That didn't make sense. I'm so sorry. That should be an 80 right there. 1 minus 0.80. Yeah, Samantha Reed.
Why did they mention it was easy?
Yeah, it has to be specific.
If you have Verizon, you can't go to YouTube.
She's trying to sell her iPhone.
Can you just change out the SIM?
I have no idea. All right, so we've checked our conditions. Any checking conditions questions? Hi, Aiden. I forgot you weren't here yesterday. All right, so now, this person, this free throw shooter, had a simple random sample of 50 free throws. I was going to do 50 here in class when we did it, but I figured that would take a really long time, so I didn't do 50. The virtual player made 32 out of 50. So there is the sample proportion. P hat is 32 out of 50, which is 64%. All right, so this person claimed to make 80%, and guess what happened? They made 64%. Clearly, they didn't do as well, right? All right, we're going to calculate a test statistic. Well, right there, standardized test statistic. It's just a z-score. Y'all remember z-scores? X minus mean over standard deviation? Yeah, you do. X minus mean over standard deviation. That's what we're finding, but it's a little bit more involved than that. All right, so next page. First of all, let's write down all of your stuff. We have a ho and a ha. The basketball player claims to make 80%. The alternative to making 80% is that he or she makes less than 80%, which is what we think will happen, right?
Wait, what was in the blank where it was like the test score?
Oh, did I not have that? I'm sorry. Oh, totally forgot about that. Let's go down here. Z-score. Oh, I said it. I just forgot to show you. The test statistic is your z-score. That's what that was. How do you find a z-score? Do y'all remember that formula? X minus mean over standard deviation?
Sure.
This is the same formula written a little bit different. It's going to be either a p hat or an x bar. Those are your two options. In this basketball player problem, is that going to be a p hat problem or an x bar problem? Very good. Y'all are getting the difference between a proportion and a mean. Good, good, good. All right. Sorry about that. I missed a whole section of the notes. Now let's go back to do this. Here, at the top up here, put your ho and your ha and your p hat. Notice in the ho and the ha, that's just a p, not a p hat. There's a difference between those two numbers. And you got to concentrate. Okay, real quick. What is my n in this problem? Is it 32 or is it 50?
50.
It's 50. Please be careful about that. I had a lot of people on the last test, which, by the way, I'll give you tomorrow. Last night I was out on the town. 50 is your n, but I had a lot of people putting 32 as their n on this, like problems like this. So be careful. All right. So here's what we're going to do. We're going to have our statistic minus our parameter. Our statistic is your p hat. It is the sample. Remember, sample goes with statistic, right? Parameter is just your plain old p. Parameter goes with whole population. So what was my statistic in this case? What number? 0.64. And what is my parameter in this problem? What's the p? 0.8. 0.64 minus 0.80. Statistic minus parameter. If you flip those, it's going to mess up your problem. Be careful. On the bottom is your standard deviation. Now, there's a formula for standard deviation, so let's look at the formula. Which one of these things is it? Bottom one. What did we just say our P was? 0.8 times 1 minus 0.8 over N, which is 50. Very good. All right. Oopsie. So, now you've got 0.64 minus 0.80. There's your formula for the bottom, standard deviation. Take your handy-dandy calculator and let's figure out what that is. You can, I would suggest doing the top and then do the bottom. But that whole bottom square root fraction thing can definitely all be done at the same time. Practice putting in the square root, 0.80, all that. Some people mess that up. Do you know where the fraction button is on the calculator? Inspires, y'all have a fraction button too. Anybody need help with fraction button? Boy, it makes life so much easier. All right, top, hopefully you got negative 0.16. Bottom, maybe 0.057. Divide those two, negative 2.81. It's still doing it. That's annoying. 8.3? Okay. It's possible that I didn't use as many decimal places as you. That's fine. Now, when you do it all, are you talking about the whole thing, top and bottom, all in one? All right. Wait just a second. If you do that, like your calculator will probably put all of that in one time, which is fine. The only problem is you've got to know that number right there. So that's why I normally do it separately. It's okay. He didn't know.
I think you should.
Emma Grace, what was your question? You don't remember? Okay, that's okay. All right, so I would suggest you do it separately because we're going to need to know what the standard deviation of this thing is. So if you have already done it right there, you know that is your standard deviation. The reason we're going to need to know it is because we're about to draw a bell curve. And in order to draw the bell curve, you need a center, right? And then you need to know the spread. The spread is how far out it goes, standard deviation. All right, so negative 2.81 is the z-score that you just found. On the bell curve, in your head, think about where that would be. Can y'all think over to the left? Right? All right. All right, next step, we're going to draw a bell curve. Yay! So, draw a bell curve. Bring it down to the bottom. Yeah. All right, in the middle of your bell curve, the center is your original proportion. What was it? What was the ho and the ha? 0.8. That goes in the center of your bell curve. 0.8. All right, how far out do we go each time? Well, that is based on your standard deviation. You just found it. What was it? 0.057, right? So you are going up by 0.057 each time, and then down 0.057 each time. Now, for time's sake, there you go. I think y'all know how to add and subtract. Maybe. I don't know. If you are running out of time on a test or on the real AP test in May, anything like that, we are going to be needing the left-hand side of this. And because you need the left-hand side, if you don't take the time to find those, that's okay. Like if you're like on a time crunch. Just find the left-hand part that you need. That's okay. Now, I said we need the left-hand side. Let's figure out why. How do I know I need the left-hand side? Let me go back to the beginning and I'll show you. Right there. You see where it says the ho and the ha? Do you notice that one is a less than? So if it's a less than problem, you're shading on the left of the bell curve. All right, where do you shade though? That's the next question. We had two numbers in this problem. We had a .80 and a .64, didn't we? .80 is the center. .64 is where you draw your line. .64 is right there, isn't it? 62, 68, about right there. And we're shading less than because this is a lower than problem. All right, x, z, a. We've done this 100 times. We're looking for .64. That's your x. How do I change it to a z-score? What's the formula? X minus mean over standard deviation. Didn't we just do it? Didn't you just get negative 2.81? I just wanted y'all to realize that that's the same thing. We did x minus mean over standard deviation. We've already done it. It was 2.81. All right, go to your calculator. I've got the 84 up here, but Inspires, y'all are going to do the same thing. Let's see. We're shading, what's the lower and what's the upper? How far low do we go? Negative 1,000 all the way up to? What? Negative 2.8 something? It sounded like you said, rah, rah, rah. Okay. Okay, so distribution. We got a whole big list here. Let's decide which one we're using. Number 2 is correct. Number 1. Hey, y'all, never ever in this class will you ever use number 1, PDF. I mean, if you go on to college and you do some more statistics, maybe. But in this class, you are never using number 1. Number 2 is cumulative density function, CDF. That means we're looking for less than. That is cumulative. So number 2 is what you're using. Lower is negative 1,000. Upper, negative 2.81. Or 8.3 if y'all got 8.3. What's my area? That's kind of little. That's like 0.2%, isn't it? That's tiny, right? 0.0025 or 0.003 if you rounded it like that. All right, that's your area. And this is interpreting the p-value. The p-value and the area, probability, they're all the same thing. This is a sentence that you're going to memorize. Kind of like the confidence interval sentence that you memorized, I hope. We have quite a while until the next test, but if you wait until 2 days before to figure this out, you're going to be stressing. I'm here almost every day after school, so if there's something you don't get, let me know and we'll figure out a time to work. But y'all know you'll be freaking out on the day before the test because you hadn't done anything about it. Why do you even say his name? All right, next problem. Flip your page. These are your 4 parts of the problem. You've done them before. A state, a plan, then the doing part of it, and then the concluding part of it. In the state part, you're writing your ho and your ha, whatever the ho and the ha may be for the problem. And your significance level. Sometimes they'll give you a significance level, most of the time. If not, then it's 0.05 if they don't give it to you. Define your parameters. That just means what is the problem about. It's either going to be a 1 sample T or a 1 sample Z. Y'all remember pizza and meat? And check your conditions. Pizza, proportion, it's a Z problem. Meat, if it's a means problem, it's a T problem. Compute the test statistic, which is a Z-score. There's a formula for that. And find the p-value. And then interpret the results. Write a sentence about it. Huh? We're not done. No. Why would we be done at this time? We're going to go back to the potato blemishes problem. I know. Why don't you make up some for us, Maddie? That'd be awesome.
Maybe we use some real ones so we can learn about oceans.
Well, I do wish, it wouldn't help y'all, but I would love to get an updated new book. Like this book was written in 2009. So if we could have a newer one.
So old.
It's only 7 years ago, but still the statistics that are in there are a little off. All right. So on these three at the, I guess it's what, middle of your page, we have discussed this before, but I want to stress it again now. If your problem has a less than symbol in it, you are shading to the left. If your problem has a greater than symbol in it, you're shading to the right. And if your problem has a not equal to sign, you're shading on both, left and right. It will say it in the problem, or it'll either say is we think that this is not equal to 64 or whatever, or it won't give you one way or the other. If it doesn't give you a less than or a greater than, you would use not equal to. This whole not equal to situation makes sense because we don't know if it's less than or greater than. We're not quite sure. So we're kind of doing both. Do you notice that the equal sign is at the top every single time? Equal is always in the HO part, the null hypothesis. The inequality, meaning the less than, greater than, or not equal to, all of that is in the bottom one every time. They don't ever switch, nor is a p-hat anywhere in there. No p-hats. All right. Okay, potato problem. This is from yesterday. Aiden, you didn't get the potato problem. It was a doozy. Was it? Might have been. I don't know. Okay, so apparently the producer determines that more than 8% of the potatoes in the shipment have blemishes. The truck will be sent away. We talked about that. We select a random sample of 500 potatoes, and inspection reveals that 47 of them have blemishes. Okay, let me stop right there. Can I get a p-hat from this problem? What would it be? 500, right? What is the n in this problem? Yes, not 47. 500 is your n. Somebody do that math for me. 0.009? Okay. Okay, so 9% are blemished in that sample. Not in the whole truckload, just in that sample, right? Their significance level is 0.10. That's your alpha level. They told you that. Alrighty. Now, is there a P? I have a P hat. Is there a P? It is. All right. I want you to get into your head and realize that there's a difference between a P and a P hat. I sure wish they would have made them different letters. Would have made life easier. But a P is for the whole truckload of everything. The P hat is just those 500 that they checked. Now, how do you check a truckload of potatoes? I don't know. How do you simple random sample check a truckload of potatoes? I guess you could, yeah.
Put in a hat.
Mixed well. An 18-wheeler size truck of potatoes. I don't know. We're not even going to go into the logistics of this, but somehow they took a simple random sample of potatoes. All right. So our ho and our ha, the original claim, and I like to write claim out to the side, although it's not required. It just reminds me that that's what the company said. There were 8% blemishes in this truckload. If there are more than 8% blemishes, they're going to send the truck back. And we talked about all the problems that would cause. My p hat was 47 out of 50, which is 9%. The alpha level is your, we'll talk more about that, but the alpha level is called your significance level. They gave you it as 10%. Now, you do have to have this little sentence. What is P? Is it the proportion of girls in my classroom? No. You've got to tell what the problem's about. P is the proportion of blemished potatoes, right? Otherwise, you're writing down random numbers that have no context whatsoever. Y'all know what context means? Connection to the problem. All right, the plan. We are going to skip the plan only because of time. I'll come back to it tomorrow, but y'all know how to do all that planning, right? Random, independent, normal. We just did it. Do write one sample z-test at the top. One sample z-test. We know it's a z because it's a proportion problem, right? And then we're going to skip this for right now because y'all know how to do random, independent, normal. And let's go to this. All right, your formula is on your formula sheet. It says z equals statistic minus parameter over standard deviation. And so I kind of wrote the formulas, but let's talk about them. What's your statistic? What's the p hat statistic in this problem? Didn't you write it down?
0.09.
All right, 0.09. Minus your parameter. That was your p. Look in the top, or I guess the last page. What was your p in this problem? 0.08. Bless you. Your standard deviation comes from that formula right there. P times 1 minus P over N. When you're doing your homework tonight, follow this example. 0.09 minus 0.08, I'll go ahead and do the math for you. Now, before you move on, just look at all those numbers and make sure you know where they came from. I think sometimes y'all are just copying real quick and you have no idea what you're writing. Are we good on all that? Richard's like, yeah. Look and see where all the numbers came from. Okay, what do you think we're going to do next? Nope. Draw a bell curve. Draw a bell curve, and before I show it to you, I want you to think about what goes in the middle of the bell curve. Hey, y'all listen. What was the original proportion for this problem? 0.08, wasn't it? 0.08 was the original proportion. That's in the middle. That's in the middle of your bell curve. And you go up by your standard deviation. That's your standard deviation. So, just for time's sake, here are all the numbers that you need. I'm not even going to worry about the back ones because I don't need those. Why did I shade to the right? It's a greater than, which is a right-tailed test. All right, there are two numbers in this problem. There was a 0.08 and there was a 0.09. 0.08 is in the middle. 0.09 is where you draw your line. Right there. Oops, I can't draw it. We're looking for 0.09. You could do your z-score formula, x minus mean over standard deviation, but I do believe we've already found it, hadn't we?
Yes.
What was it? 0.83. There you go. Go to your calculator and see what the area, which is the p-value, would be. 0.83 is your lower, 1,000 is your upper. I think it's big, 20-something. You got it. 2033. Right? All right, this thing is called the area. That's the area under that curve, but it is also called a p-value. That's what your p-value is. Now, we're going to have to stop. But I do want to show you this one thing. We'll write the sentence later. So like on the homework, if it asks you to write the sentence, it's okay. Your p-value is 0.2033. My alpha was 0.10, wasn't it? Is my p-value low, reject the hoe? No. This one is going to be a fail to reject. Because p-value is not low. And then we'll stop right there. We'll do the sentence tomorrow. That was a lot, wasn't it? Try these problems. Multiple choice. One of them is multiple choice. Yeah, I think these are multiple choice right there. So it's really only two actual problems.